Yeah, hello everybody. Just quickly introducing myself, Michael Merz from Ponton. As Ponton, we have been doing B2B integration already for 18 years. And so our focus is on B2B integration, specifically in the energy sector and very specifically in the energy trading sector. Our background has been over the most years in post-deal processing, so confirmation matching, regulatory reporting under REMIT and EMIR and such regulations. Also clearing, spot market clearing. And my personal history is I studied computer science. I received my PhD in the 90s, and part of my PhD thesis was e-commerce, and part of e-commerce again is payment. And in the course of dealing with that topic, I came across eCash, which was the very first cryptocurrencies back in the 90s, and that somehow enlightened me regarding cryptocurrencies at that time, but also later, of course, regarding Bitcoin in the year 2011, and then again later regarding blockchain. So about 3 years ago, with our B2B integration expertise, we expanded also into the blockchain field, specifically as this is applied to the energy sector and also energy trading. However, yesterday we had a discussion at the presentation of the DENA study on blockchain technology and energy in Berlin, if I'm a blockchain skeptic. And I said, no, I'm not a blockchain skeptic. I like blockchain. I'm only blockchain agnostic, yeah? Which means that out of these many possible applications in the energy sector, in energy trading, in other grid management fields, there are a lot of applications, and to my opinion, most of them are classical applications, and it will be a hard time to implement them based on blockchain technology, whereas blockchain applies maybe to a very small minority of process types. In my opinion, energy trading, as far as wholesale trading, is one of them. But I'm quite skeptical regarding other applications where I don't always see really maybe a use case, but probably not a business case. Yeah. So what I'm focusing on now is Enerchain as a project. Let me proceed. This is the second introduction slide. I put this here because there is the Ethereum logo, and this is not perfectly correct because we are using Tendermint, and we have extended Tendermint as a consortia blockchain for permissioned participation, and that is the wormhole framework, which has been developed on top of Tendermint. But I will come back to that later, and also why, because we also analyzed Ethereum, and we came to the conclusion that there are still some shortcomings which keep us from using Ethereum. But let's first start with the content. The project that we are doing can be structured alongside the traffic light model, if you like. So the projects can be done or can be categorized by copper plate related projects, or versus the yellow traffic light phase, which is prone by upcoming congestions in the grid. And then of course there's the red phase where we have the DSO controlling resources and doing curtailments and switching on and off producers or consumers. And then there's the other axis where we have the wholesale market, which usually focuses on the balancing zone or market area layer. which is Germany, or which is the 4 balancing zones in Germany, or in all other countries, it is the balancing zone equaling the market zone. And that is what Enerchain focuses on. So these products here are, let's call it classical energy products, like forward products, yearly baseload contracts, quarterly, monthly, weekly contracts for gas or power. It could also be in the spot area, well, it's with physical settlement. Yeah, so we are not talking about futures, financial products, but just physical products which are traded OTC. So not on the exchange, but basically using brokers or bilaterally. Then there, let's say one level lower, flexibility trading is another topic. Here we talk about local deliveries of energy in order to help relaxing the grid situation. This might be within the DSO areas, or it might be also regarding transmission grids. And what we are doing here is part of the new for Zero project. For the German guys among you, there are these 5 Syntec projects in Germany, which have been initiated by the Federal Ministry of Economics and Energy. And these projects focus on trying to mitigate congestion situations that frequently come up in Germany because of the high generation rate in the north, specifically where the wind farms are located, versus the south where the demand is located, the industry. And for TSOs like TenneT, for example, this means a strong bottleneck because this high production capacity and this high load cannot be really transferred down to the south. And the idea is, of course, to find solutions to mitigate this by unlocking flexibility at different grid layers. And then there is another project that we are doing. There are more than one project that we are doing in the microgrid, at the microgrid level or at the local grid. One is ET-Block. It's also a project sponsored, supported by the ministry. This is real-time trading between prosumers and consumers, an area where we have, I would say, about 100 different projects in Germany alone. We also do other projects, but these are bilateral projects with the industry, and here some NDAs apply. So I will focus today on Enerchain and on how this all started. And it all started actually 3 years ago, when the Brooklyn microgrid became visible. Yeah, that was the big bang. That was the first energy trade on blockchain, on Ethereum, and that inspired a lot of activity in the scene all over the world. So also on the Ponton side, and it also inspired us because we also felt as a B2B integration company being in the right position also to think about energy trading in a decentralized way, and apply that first to wholesale trading, but then also later to the other grid layers. And the first thing I did back in May 16 was to write a book chapter on that. Yeah, and that had been it was a German book. But the chapter was translated into English, potential of the blockchain technology in energy trading. I used this to sort out for myself how this all works together. Yeah, the energy transition on one side, the need for mitigating congestion situations and flexibility, the wholesale market, the development in the wholesale market, what will we see potentially in the year 2030, what type of energy will be traded? Do we still need forward markets, really? Or do we have so much capacity that it's only a short-term question of how to distribute the generated energy to the consumers and others, probably. So that was the topic. And then soon later, in the summer, we developed a prototype. And at that time, it was really exciting to do something like a distributed market, because that didn't really exist, a distributed market before. So that was tapping into quite new, unknown areas. And as a result, later in the year, we presented that on a conference in Amsterdam, on the EMAT conference, and that was really a highlight, because it was really the first energy wholesale trade over the blockchain, presented in front of about 100 people participating in this. We had two traders, one from Holland, one from Belgium, who traded at day-ahead delivery of power within the market area of the Netherlands, which was reported as a wholesale trade under REMIT to ASA. So that was a fully fledged trade, but it happened on my laptop. So there were two nodes installed on my laptop, and we just simulated a blockchain distributed across the community of participants. But it was a blockchain-based trade, and it showed how it works. So it was a proof of concept, if you like, or it just not just demonstrated that it works, but it was a real trade after all. And that inspired a lot of people to think deeper about what this means and how this could be applied. And as a result, we had a lot of discussions with energy trading experts and with trading organizations between this event and spring 2017. And because there was so much interest, we invited over 50 people from all over Europe, basically coming from energy trading organizations with front office background, back office, IT, legal, regulation, compliance, all different kinds of experts. We invited them to participate in a workshop to further hammer out what could be done with the blockchain in energy trading. Just to reaffirm if we are on the right track. And so we asked them, what would you like to do, to cut it short? And the result were two main topics. One main topic was called get rid of the broker fees. So this would be cutting out the man in the middle as a broker who runs a platform, a third-party platform, which arranges trades for market participants. And the idea here was a cost reduction, achieve a cost reduction regarding external transaction fees. And the other one was bring down settlements to D+1, which is also a very specific topic in energy trading, but I don't want to expand of that because it would take too long otherwise. So this all expanded. We started then in May 17 with 23 participants, and later on, a year later actually, again in October 17, on that same type of conference on the EMAT, which took place again in Amsterdam, we did another couple of live trades, but this time it was based on the software that we developed in the meantime. And this time, the blockchain, which is a proof of authority based blockchain using Tendermint as a consensus mechanism, that was located on different nodes, again located across different clouds. And the participants were real traders sitting at their trading desk in in Budapest on the E.ON side, and in Rome on the Enel side. And E.ON and Enel did another trade, another live trade over this blockchain. And the interesting thing is, we as participants, Ponton, we were connected to the blockchain, but of course we couldn't see who the others were, yeah, from the order book, because this is anonymous. Of course, we knew that who the two were, but in principle, third parties don't see who really enters into a transaction. So this is like on an exchange or on the broker platform. You see orders in the order book, you see the price, you see the quantity, you see the product for which this order book exists. But you don't see who has put the order there. And that is exactly the same situation that we implemented in a decentralized way. So further, the number of participants grew to 45, and we tackled a lot of questions and issues. Yeah, so that was not just the technical issue. There were regulatory issues. There were governance questions we discussed. There were contractual questions. A lot of topics which took quite long, actually until Q4 2018, until recently. Yeah, that is the so-called proof of concept project. So over this time, we had a lot of live trades, but it was not a continuous trading. Yeah? It was arranged trades to exercise the decentralized trading and to prove that it works and how it works. But still, even now, there is still a path to go until this is a continuous business, until this is running continuously. The next steps, I don't have them on the slide here, but the next step is to go live with Enerchain 1.0 in May this year. And for the Enerchain participants, there's another workshop later in March to prepare that. And we have now subgroups who each focus on specific products which are not mainstream products as they are traded on existing platforms, but more focused products. So this is a bit about the history and how we got there. These are the participants. I think I'm just going to skip this. Next slide, also to not run out of time too much. How it works. Here we see the trading screens of the market participants. 4 in this case. Of course, realistically, that would be many more. And we don't see one player in the middle, being the broker, for example, but instead we see 6 nodes, or better would be 7 nodes or 10 nodes, yeah, because of the consensus mechanism, which is PBFT. And yeah, I come back later to that. So what we see here are applications which are linked to the nodes, and the trading takes place by having a trader on this big screen entering an order and hitting the submit button, and that order will not go to a central order book because there's nothing central. The order is just a message, and this message is, from a blockchain perspective, a transaction, and the transaction will go into the next block. And as the next block is finalized, it will go from the nodes back to the application sphere where each of these market participants are connected to. So it is key for trading to be as fast as possible, which means that we have to reduce the block time here to a time span as short as possible. And what we achieved using Tendermint and also in the Enerchain project was to use a block time of 1 second, because finality has to be reached as fast as possible. And what we achieved here was to reach finality after 1 second. So a block time of 1 second plus 200 milliseconds for the consensus mechanism, which is extremely fast, with 7 nodes involved. And which means that after, on average, 0.7 seconds, a message, which is an order, for example, reaches the application on the other side, the different market participants. Why 700 milliseconds? Because whenever an order is submitted, it might be at the beginning of a second or at the very end of the second. So on average, this is half a second plus the 200 seconds for the consensus mechanism, giving altogether an average latency of 700 milliseconds. And this is also a shortcoming still, because we don't address high-frequency markets, because high-frequency markets process thousands or 10,000s or even more of transactions per second, and the latency is in the range of microseconds even. Yeah, so that won't work. That just won't work. But on the other hand, there are a lot of markets out there in the world which are less liquid. Yeah, where we have a couple of hundred or thousand transactions a day per product, and where every minute something happens. Yeah, so an order is submitted to an order book in minute 1, and maybe a minute later another order comes in, or the order is updated, or it's executed. So it's very rare that we have these high frequency situations for many products out there. And that is exactly where the focus lies. Yeah, so it's the medium liquid markets, or also less liquid markets, but not high frequency trading. In the real world out there, as you can see, there are not just persons using Enerchain, or in general exchanges or brokers, but trading robots, and that is the future. So the trading will more and more be done by automatic software tools, and that was also the case with Enerchain. So that's the principle. And why did we use an own solution? First thing is, we needed a very fast block time. If we look down to the existing solution, what is already there? Ethereum was not useful, because here we have a block time of 15 to 20 seconds, and finality is reached really after, well, how many? 3 or 4 blocks? So it would be after a minute. And if we have a minute as a wait time for the trader, he could go to the coffee machine, have a coffee, could go back to his trading screen, and would then be able to see the results of an execution of a trade, or possibly not. Yeah, so this doesn't make sense. It would take too long. Also, faster blockchains like Steam or others have a block time of 3 or 5 or 10 seconds. That would take too long. Yeah? So we really had to optimize the system with the goal of having to be as close to real time as possible. Using Hyperledger Fabric was also intended, but it also didn't work, because the problem is that if you have 100 participants, and if you want to use the endorser function of Hyperledger, the endorsers would be the 2 parties to a trade, the buyer and the seller. And this would mean that everyone would have to install a node, an endorser node. Yeah? And that would be probably overkill for many of the participants, because the solution should be that the nodes are distributed among some of the participants, and this would be 7 or 10 nodes, but not all of the 100 participants should do this. Yeah? And if you look at the flexibility markets, or if you think of smaller scale products or lower transaction volumes, where maybe there potentially are 500 market participants, you cannot do this under the assumption that everyone runs an own node. That would be too much overhead. And then also other blockchain technologies didn't really work here. Another requirement was partial encryption of the data. Because an order should be visible for everyone, and therefore most of the data should not be encrypted, which is fine, which would work with Ethereum. But one very important part of the data must be encrypted, and that is the ID of the one who submitted the order. So, and that means encrypted in the sense that the ID should be anonymous. The initiator, the one who submits the order, must be anonymous and not just pseudonymous. Because if you let such a market run for a week, you could easily detect after some time that from the behavior of a market participant number 4711, that this must be E.ON or RWE or Enel or Endesa or whoever. Yeah? So it must be anonymous. Problem, Ethereum is not anonymous. And second problem, the data is stored in the blockchain in an unencrypted way. So that would not work. And also with hyperledger fabric, we had similar issues. And then the next problem was that we simply for regulatory reasons could not use smart contracts to implement the distributed trading. Why? Because if the nodes are hosted on the participant side, and if on these nodes smart contracts are executed, and if a participant executes or proposes a new block for example, on the Ethereum blockchain, it is this participant who would decide that two other participants would be matched. Yeah. So from a regulatory perspective, this would be a no-go because that participant would be treated as a platform. Yeah. And this is avoided by the participant. So for certain regulatory reasons, it also didn't work with Ethereum. Own design, that was our solution. So as a result, and as a conclusion of a lengthy analysis how to proceed here, we used Tendermint, which in principle allows to achieve a transaction rate of 10,000 transactions per second. But forget it, yeah. Like all these other great numbers of 100,000 or more or less transactions per second, what actually counts at the end is the end-to-end rate, yeah. And that is never thousands of transactions or 100,000 of transactions. It's rather 50, yeah, or 100, because there's so many layers of encryption and communication in between and there is the consensus mechanism. If we talk about a blockchain and not about Kafka, for example, that at the end, the real throughput is much lower than what is technically achievable. And even the 10,000 which we validated ourselves, the 10,000 with Tendermint, was under best lab conditions. Yeah, one or two nodes on the same processor, zero validation effort, and only for a couple of seconds. So these are lab figures which you can simply not trust, and which don't really apply for practical applications. So Tendermint, on the other side, and that's the flip side of this, is just a consensus mechanism and nothing more, not much more. Yeah. So we needed to add additional layers in order to transform Tendermint into a consortia blockchain. And what we did here was to add logic. I have to see there's some people trying to come in. It's a bit difficult to do that at the same time. So what we did was to add a middleware layer on top of that. And this consists of two components, or two layers, two sub-layers, if you like. One is co-located with the nodes. These are the node adapters. And the others are co-located with the clients or with the applications. And these are the client adapters. And the node adapters are used, for example, to store certificates, to exchange certificates, to provide an interface for client adapters to connect to. And the client adapters, again, they store logic which is located within the sphere of a participant, within the organization of a participant, and which allows to connect to the nodes through the node adapters. And if something should fail on the node adapter side, the client adapters immediately switch to another one within a couple of seconds, such that at the application level, there is a certain level of transparency regarding such switches. Yeah? So the goal here is, from a software design perspective, to allow applications on top to synchronize each other regarding a global status, and this is exactly what blockchain is used for. Blockchain is an asynchronous mechanism to synchronize applications, and this is exactly what we are doing. We're synchronizing applications on top, which are these gray-red boxes above the client adapters. And whatever the process is, that doesn't necessarily need to be energy trading. It also doesn't need to be any kind of trading. It is a process, a distributed process, which is used to synchronize software applications. This is a byproduct of what we develop, and that in a very fast way. So within 700 milliseconds on average. So this is how Enerchain is designed. Everything blue is horizontal. This is the wormhole framework, as we call that. Everything red is process specific, is application specific, is vertical. So of course the trading screens are vertical on the very top, yeah, or the trading robots which use the client adapters. And then also vertical are plugins that we use on the client adapter level and also on the node adapter level. And these plugins carry application-specific logic. For example, validation. Yeah? So it is a core part of the blockchain underneath to validate blocks, yeah, and transactions. And whenever a validation takes place, you cannot expect that from the horizontal layer of the nodes. So what you need is an upcall to the node adapter in order to invoke the application-specific plugin in order to perform the validation, and then provide back the result of the validation to the node, and in order to perform the consensus mechanism. So we generalized this, and we created a framework which can be applied to any distributed application use case where a large number of participants need to synchronize with each other through blockchain. So our approach here of the wormhole middleware is quite far away from cryptocurrencies. It's also, in a way, it doesn't actually follow the way how smart contracts are implemented with Enerchain. You may call this chain logic here on the node adapter side smart contracts because it resides on the node, but it's much more under control of the software developer, what logic to put there and what not. And we don't use gas, for example, because this is clearly designed for consortia purposes. And as we have already a much more organized and coherent setup with a consortium, which has a certain trust level with one another, we don't need all these features that you find with permissionless blockchains like Ethereum or others. So that is the architecture approach to support Enerchain, and that's it already. So yeah, last slide. I talked far too longer than planned. If you would like to get more information, come back to me, drop me an email. There's also an Enerchain website, which is lousily maintained because it's me who maintains that. You also can find some information about the wormhole framework. By the way, we are also going to have some events coming up in later spring around the wormhole framework, because we believe that wormhole can also be used for non-energy purposes in other sectors. Yeah, we are talking to people in the insurance sector, we talk to people in the logistics sector, and we also talk to people in trading industrial goods. And the ability to make obsolete a third party as a broker for trading other goods than energy is amazing, because in other sectors they just don't trust the third party. So there is no third party, and if a third party was to be introduced, they would just not trust them. This is well, sector specific, I would say. In energy, we don't have that situation, of course. Third parties who organize markets are trusted in the energy sector. That's very clear. As far as energy wholesale trading is concerned, it's just the cost reduction. But there are other sectors where, on top of the cost reduction potential, there's also, for trust reasons, an appetite for decentralized trading, because they don't want a third party. Okay, and finally, of course, there's the book which recently appeared, and I hope it can also be ordered, because it took some time to make it available through the classical wholesale channels. Maybe in a couple of days it can also be downloaded, but you can also order that on the book website. And if you are interested in further aspects and further info, just have a look at the videos which we recorded some weeks ago. They're also available in English, so just go to the book website and go to the blog there. We will find a page with a lot of YouTube videos on the blockchain potential in B2B integration.